Hi guys, welcome back. By this time you've heard that we have only 4 more weeks of school left. So I just wanted to reiterate to you guys how proud we are that you guys keep tuning in every week. You're taking such amazing notes and we are so proud that you're learning from home, as we know it's not easy to do. So stick with us for the next 4 weeks and then we're gonna be on summer vacation, just like that. So today what we're going to do is jump into Unit 10, which is called the Sequences Unit. On the top of your paper, I want you to date it. So these are notes from Monday, May 11th. It's going to be Unit 10, and these are sequences. Okay, and what sequences are, you've seen sequences before. They're lists of numbers that go in a specific order and follow a specific pattern. Okay, so the 2 types of sequences that we're going to teach you are arithmetic and geometric. We're going to look at both of them today, and I'm going to tell you the difference between the 2. What I want you to do is leave a chunk of space about the size of an index card for some vocab. We're going to come back to it, so just leave yourself a chunk of space here. We're going to put some vocab or sequence notation in here. This is going to be new stuff. You guys have not worked with sequence notation before, so it's just going to be important to learn this new type way of writing a sequence. But what you have seen before is sequences. So I'm going to show you the 2 different types. So you're going to have the last part of your paper here, we're going to divide into the 2 different types. So just leave room, and I'll try to model it with what I'm doing. As always, the notes I take, you take as well, okay? So everything I write, I want you guys to write on your paper. This is part of your work that you're gonna be handing in. Okay, so the first type of sequences are called arithmetic sequences. So go ahead and write that on the top here. Arithmetic sequences. And what makes a sequence an arithmetic sequence is if it adds or subtracts, if the numbers add or subtract by the same amount. Okay? Other sequences that we're used to seeing that add or subtract by the same amount are linear. So arithmetic sequences can be compared to linear equations or linear functions. Okay, so it's just nice to know, or it's important to know, that arithmetic goes along with linear functions, okay? Now on this half of the paper, I'm going to show you what an arithmetic sequence looks like. So it could be something like this. Here you see lists of numbers 3, 6, 9, 12, 15, 18, ... Okay, this is considered an arithmetic sequence, and we're going to talk about why in a second. Another type, and make sure you leave a chunk of space on this side because we're going to be writing our actual sequences, recursive over here, so just leave that space. I'm going to do 2 examples of each type, so 4 examples total. Okay, so here's your first example. Skip a little bit of space. You don't have to skip too much. The second arithmetic sequence is 10, 8, 6, 4, 2, ... meaning that's going to continue on. Okay, and if you have highlighters, this would be a good lesson to have a few different colors. I'm going to use 4 different colors throughout this lesson. If you have 3 or even 2, that would be really helpful, just to point out some of the important things and see some patterns as we write. Okay, so let's talk about why this is an arithmetic sequence. These numbers go in a specific order with a specific pattern, and I told you that arithmetic sequences add or subtract by the same amount, okay? So they add or subtract, that's really important to know, and let's figure out what these ones are adding or subtracting by. So in order to get from 3 to 6, I add 3. 6 to 9, add 3. And that pattern continues throughout my entire sequence, which makes it an arithmetic sequence. It has to be the same pattern throughout. I can't add 3 and then multiply or whatever it might be. It has to be added by the same amount each time, okay? For example number 2, to get from 10 to 8 and 8 to 6, I would subtract 2, making this an arithmetic sequence because I'm subtracting by the same amount, okay? This one I'm adding, this one I'm subtracting. Arithmetic, add or subtract by the same amount. Okay, so this is pretty basic right now. This stuff you should be okay with. I'm going to skip a little bit of space, and you can draw another line if you want, or you can just make your new title. We're going to move on to geometric. I'm going to stick with black here. Geometric. Geometric. Okay. So geometric sequences are different from arithmetic in that they multiply by the same amount. Okay? And we don't say multiply or divide. We just are going to use multiplication, and you'll see how that works in a second. Okay, so these are going to be multiplied by the same amount. I'm going to highlight that in just a different color here. Okay. Geometric sequences are comparable, or they're the same as exponential functions, which we just did in Unit 9. Exponential, exponent, I can't spell and talk. It's a oh, I did forget it. Exponential equations. I don't know why it's something I can't do, spell and talk at the same time. Okay, so I'm going to give you two examples of geometric sequences right now over here. So example 3 is going to look like this. 2, 6, 18, 54, 162, dot, dot, dot. And your fourth example, 80, 40, 20, 10, 5, dot, dot, dot. Okay, these are two examples of geometric sequences. And the reason being is because they're being multiplied. Each number is being multiplied by the same amount to get to the next number. So for example 3, it's easier to tell. First of all, I would look at the sequence and see how it grows super fast, just like our exponential equations do. They start small and then shoot right up. And I would know right away to start thinking, okay, these are being multiplied by the same amount. So to get from 2 to 6 and 6 to 8, I times by 3, multiply by 3, and that pattern continues throughout. And you could double check yourself if you're not familiar with that math, but it is all being multiplied by 3. For example number 4, now these numbers are going down. So our natural instinct is to say they're being divided. But just like in an exponential equation, we want to figure out what they're really being multiplied by. So in order to multiply and have your numbers decrease, you multiply by a fraction. And if you're unsure what that fraction is, the trick is you can always take one number and divide it by the one right before it. And that will work in any part of this sequence. So I could take 10 and divide it by 20, as long as it's the number right before, and it will tell me what I'm multiplying by. So I'm going to do 40 divided by 80. And then I like to see it as a fraction, so I hit math button right there, enter, enter, 1/2. Okay, so that's what I'm multiplying by. Times 1/2, times 1/2, times 1/2, and times 1/2. Okay? All right, so I'm hoping at this point of the lesson, what I want you guys to soak in is that arithmetic sequences add or subtract by the same amount, geometric multiply by the same amount, okay? Now let's get into some sequence notation. This is going to be new stuff to you, so this is where I need you to really tune in. If you need to pause and replay some things, that's okay. It's going to look uncomfortable and it's going to look a little weird, but it really is not. It's as easy as what this was. Okay, you just kind of have to get used to this new notation. So sequence notation, why don't you go ahead and put that right here. Sequence notation on the top. And just like in a foreign language, I'm going to teach you what a couple of these different, they're not really words, but different types of notation, what they mean in words. Okay, so if you see something that says A1, or it could be F1 or D1 or P1, it could be really any letter here. But if it has a subscript is what we call that little number on, like, it's kind of like an exponent, but exponents are high. This is low, so we call it a subscript. This means the first number in a sequence. So you could probably figure out if this was A of 2 or A of 3 or A sub 4, we would also say that's the fourth number in the sequence. A sub 5 would be the fifth number, and so on. Okay, that should make sense to you. A of n, so I'm sticking with the A's, but again, it could be any letter. It could be F. We see F sometimes. A of n means any number in a sequence. We use n to just represent any number. So this would be any number in a sequence. Okay, moving along. This one's a little bit more complicated, but it should still make sense to you. A sub n minus 1. Okay, and the way we say that is A sub, meaning I'm going down, sub n minus 1. Okay, if you compare it to A of n, and I just say it's n minus 1, it's the number before n. Okay, so what that means is the previous number in a sequence. So it's the number before or the previous number. Or the number before. They mean the same exact thing. I might say one of each, it might use different terminology each time. I might say the number before or previous number. You just need to realize A sub n minus 1 means previous number or the number before. Okay. The other terminology you need is we're going to be using the letter D to represent something called the common difference. And that is what we're going to be adding or subtracting our sequence by. So we're going to see that, so adding or subtracting, we're going to see that in an arithmetic sequence. We're only going to use D, or common difference, in an arithmetic sequence. Okay? We're going to use the letter R to represent our common ratio. And that is what we are going to be multiplying our sequence by. So in that case, multiplying would make it a geometric sequence. So you're only going to see that in a geometric sequence. Okay, so arithmetic sequence for that one, geometric sequence for common ratio. Okay, and the last terminology or the last terms I want you to, I guess this would be a vocab definition, is what is a recursive formula? This is what we're going to be learning today. When you hear me say the term recursive formula, that's a formula that you're going to write where each term depends on the one before. So we're talking about sequences. A recursive formula is going to be written when each term depends on the one before. Depends on the number before it. So it's a sequence that builds on each other. You need to know the number before in order to find the next number. This will make more sense to you when you actually see this today and in our next lesson. Okay, so in the section to the right, I want you to kind of split this and go ahead and split this. And we're going to be writing recursive formulas for each one of these examples. Recursive formula, this is going to be your recursive. Okay, and once you get the hang of it, we're going to use the sequence notation, and I'm going to try to teach you a trick on how to write recursive formulas. Once you get the hang of it, they really are quite simple. Okay, so take one color of a highlighter that you haven't used yet. If you've already, or if you don't have 4 colors, it's not a big deal. But I'm going to highlight the kind of what I call the skeleton of the recursive formula in blue. Okay, and what I mean by that, each recursive formula needs a couple of things. A skeleton, you're going to write it every time you see something that says write a recursive formula. These are the parts that you're going to need. So every recursive formula needs your A1 defined, meaning I need to say, okay, what is the first number in the sequence? Then the next part uses these two pieces. The next part of a recursive formula says any number in the sequence, A of n, equals the previous number, A sub n minus 1, and then whether or not you have a common difference or a ratio you'd put there, which I'll talk about in a second. So in blue, I box in a big L to remind me, and I leave some space. A big L to remind me that these pieces right here have to be in every recursive formula. So you're going to see this exact thing down here, down here, and down here, okay? This means the first number in the sequence. This means any number in the sequence is equal to the previous number, and then we'll talk about what else you put there. Okay, now I'm gonna use a different color to represent the first term in the sequence, so that I'm gonna put here. And then I'm gonna go back to my orange, because I already used it. For my common difference, adding and subtracting is my common difference, okay? So these two pieces are what you're gonna see added into my recursive formula, okay? So my first number in the sequence, that's the easiest one to find. It's the first number written, okay? So in this case, it's 3. So I'm gonna put the 3 there. My first number is 3. My common difference, what am I going up or down by? Well, I happen to also be going up or down by 3. Why do I always pick the same numbers? And I don't realize until I'm halfway through the video. Okay, it's the number you're adding or subtracting by, okay? So since I'm going up by plus 3 each time, then I'm gonna put plus 3 here. And that is how you write a recursive formula for this sequence right here, okay? So this sequence, I'm gonna say it how it would be said in words. The first term in the sequence is 3. And any number in the sequence is equal to the number before it plus 3. And that should make sense to you. Okay, if I'm looking for the third number in the sequence, it would be the number before it, 6, plus 3. And that would give me 9. So that would be the third number, okay? So recursive builds on each other. You need to know the number before in order to get your next number. All right, so in blue again, I'm gonna draw my little L to remind myself of the pieces of a recursive formula that I always need to write. So you always need to write A1 equals your first term defined, and then A sub n, A sub n, any number in the sequence, equals A sub n minus 1. Okay, and then I need to just find my first number and my common difference. Okay, so the first number in this sequence is 10, and I should have highlighted that in yellow. So my first number in that sequence is 10. I'm gonna put a 10 here. And then I'm going down or subtracting 2 each time to get the next number. So my common difference is gonna be minus 2. Okay? So your recursive formula, this one says your first number in the sequence is equal to 10. And then any other number in the sequence equals the number before it minus 2. Okay? All right, moving right along to geometric. You know, I'm going to actually write out in letters so that you can see each recursive formula for arithmetic is going to look like this. I'm just going to add this to your list here. So the first number defined, A1 equals, I'm just doing this for any sequence, so I'm not going to write a number there. And then any number in the sequence equal to the number before it plus or minus your common difference. Okay, so that's the recursive formula for arithmetic. The nice thing is that geometric looks almost identical, except for what we do. Instead of our D, we're going to use our common ratio, and instead of adding, we're multiplying it. So I'm going to show you that right now down here. So again, I'm going to draw my little L. So why don't you go ahead and write recursive formula so that you have this. Recursive. I'm going to draw my L. And if you don't like the L, you really don't have to use it. It's been helpful in the past for students to remember the parts that they need for a recursive. Because this little box reminds me I need my A1 defined. And then this reminds me I need my A of n equals A sub n minus 1. Okay. Now I'm going to show you what the geometric sequence looks like in comparison to the arithmetic. It's just a little tiny bit different. So this one, you have your L again, and I should have done that in blue, stay consistent. Where I have my first term defined, A1 equals, and then A of n equals A sub n minus 1, and then you multiply it by your R. okay? And you can multiply it by your R, and I'm gonna highlight the R's in green here, either in the back, or you can put it, that could also have been in the front, okay? In this one, I'm gonna do it behind, and then in the next one, I'll show you it in front, okay? All right, so let's go find the two pieces I need. So I need just my A1 and my R in order to write a recursive here. I needed my A1 and my D for arithmetic, geometric, multiplication. I need my first term and my common ratio. So the first term in the sequence, in this case, is 2. So my A1 equals 2. And then what am I multiplying by? I'm going up by times 3. Multiplying by 3. So you don't show it like, I'm not gonna show a times symbol. I'm gonna just put parentheses around here and put a 3. This is like the distributive, it kind of looks like the distributive, or you know when you have a number next to parentheses that you multiply, okay? So just know what it would be, whatever the number was before times 3. So for example, if I wanted the second number in the sequence, I wanna know what this number is. I would take the number before it, 2, pop that in there, multiply it by 3, and I would get 6. Okay, so that's just what that's showing. You're gonna get practice actually using the recursive next lesson. All right, and then for my last example, I'm gonna draw my little L. Again, optional, you really don't have to do it if you don't want to. I'm gonna do A1 equals, and then A of n equals, I'm gonna leave space in front this time, A sub n minus 1. And in front is where I'm gonna put my common ratio. And here is where I'm gonna write my first term, okay? So my first term in this case is 80. So I'm gonna go ahead and put 80 in here. And what am I multiplying by? Is 1/2. So that goes out in front with parentheses around your A sub n minus 1 to show you're multiplying, okay? So that is how you write recursive formulas. This is what we want you to do for practice on the back, okay? I'm gonna give you guys 3 different things to practice. So go ahead and flip over. These are gonna be your follow-up questions for today. So write follow-up for 511. Question number 1 is gonna ask you to define some of the terms, okay? Because that's what really is the most important part of understanding sequences, is knowing what each piece means. So I want you to tell me what A1 means. You're just writing that out in words, okay? I want you to tell me what A sub n means. I want you to tell me what A of n minus 1 means. What does D stand for, and what does R stand for, okay? So just define those 5 terms. Then, I lied, I'm gonna give you 4 questions, sorry. Okay, but they shouldn't be too bad. Okay, question 2, I want you to, for all of these questions, so you can write above this, write the recursive formula for the sequences below. Okay, so the sequence is going to be 7, 11, 15, 19, 23, ... You can write your recursive here if you want. Number 3 sequence is going to be 1, 4, 16, 64, and 256. And the fourth, or the third sequence, fourth question, is going to be 81, 27, 9, 3, 1, and 1/3. Okay, so why don't you write your sequences right next to them? You can draw your L box. You can draw your L's to remind you how to write the recursive. But I want to see them right here. And remember, the question you always have to ask yourself is, before you begin, is it arithmetic or geometric? Before you begin, okay? Are you adding or subtracting, or are we multiplying? Okay, arithmetic, adding or subtracting. Geometric is multiplying, okay? We're gonna go over these questions in the next video, so make sure you do them, and then we'll correct them in a different color so I can see the difference. So I know you did it and then corrected it, and so I can see your mistakes too, and so that most importantly, you can see your mistakes. And And we'll do that on Wednesday, okay? Thanks again, guys, for tuning in, and I'll see you Wednesday.